for good.
This just made my whole day.
All right. F of x, just think of it as y, same as the last chapter. By the way, a lot of you guys did really good on that stuff, right? What is that x in that thing? What is that 2 there? It's a power, otherwise known as an exponent. So that's an exponent of x. You played around with them algebraically in grade 11 and grade 10 mostly, but you didn't really graph them. Okay? We're going to graph them. That's an exponential function. X is the variable. It varies. Okay? Depending on what x is, that'll give you what your output is, and we're going to graph that thing and see what it looks like. So some restrictions here. If a is 0, it doesn't make any sense, right? It's just a 0, and that's not very fun. And we're not even going to look at the negative values of a here. They would in pre-calculus, but we're not going to. So a is restricted to just positive numbers. And they're probably going to be integers, whole numbers. B is going to be greater than 0. Okay? Again, if it's 0, it doesn't make very much interesting graphs. And b can't be 1, because of course if x is 1 there, again, it's a boring graph. It's not very exciting. So first example we're just going to kind of play around with is, I'm just going to let a be 1 in this exponential function. So in other words, I don't need to worry about it. It's just going to be b to the power of x. I'm going to put a couple graphs here, and we're going to see what happens. First, for values where b is greater than 1. Okay? So let's let b be 2. My graph is going to be f of x is a is 1. I can put it there, but it's not going to do anything. And b is going to be 2. So I'm going to graph that. Just quickly. Okay? Window has got to go back from negative 10 to 10. And again, on your final, you guys are going to have sine functions. You're going to have polynomials. You got to check your window. Okay? You got to go back and forth, depending on what you're getting asked to graph. Okay? You can't just show me your calculator and go, Mr. Watson, it ain't working. If I'm nice, I'll say, well, check your window. That's not what I want to graph. Right? But you kind of, part of the expectation is you guys need to know how to work this thing. All right. Those I don't want anymore. I want to graph 2 to the power of x. And there it is. Now it looks like it comes right out of the origin. It doesn't. I'm going to actually blow this up just a little bit. I'm just going to go from 5 to 5 because I'm trying to make a point here. It still looks like it comes out of the origin. All right? There's a point here, 1, that it goes through, and it increases as it goes that way. There's an arrow there. X can be as big as you possibly want to graph, right? Is there any restrictions on x here? No. And in the negative side, it looks like it only goes to about negative 4. But could I put in negative 10 in here? Sure. And if you remember negative exponents, don't write this, but the first thing you do, we were taught in grade 10, is you don't want a negative exponent. You want to flip that thing down there and make it positive, right? So that's 1 over 2 to the 10. 2 to the 10 is 2 times 2 times 2. It's a big number. What's 1 over a big number? A really, really small number. They keep getting smaller and smaller and smaller. But that thing doesn't stop right there. Okay? There's an arrow on there. It keeps getting smaller and smaller and smaller. Could I put x equals negative 100? Sure, I could. And it would be 1 over 2 to the 100th. It's not 0. It's a puny, puny number, but it's not 0. It's never 0. It keeps going on forever and ever and ever in the negative direction. There's a word for this axis here. It's called an asymptote. All right? This line keeps getting closer and closer to it, but never, never touches it, even though it looks like it on the graphing calculator. Okay? So that's what that thing looks like. Now I want to try b is 5, right? So my function is just going to be f of x is 1 times 5 to the x. And let's see how that thing looks. 5 to the power of x. Quite a bit steeper, right? Does that make sense? Because when I take powers of 5, 5 times 5 is 25. 2 times 2 is only 4. So it's going to get a lot steeper as x goes. But does it look like it goes through the same point here? It does, right? And what happens if b is a real bigger number than 10? Any guesses? If f of x is 10 to the power of x, any guesses? Probably you'll get even steeper still, right? And it does. So it should show that it's a lot steeper than this guy, 5. But the left side looks pretty similar, doesn't it? Okay? What do you notice about the y-intercept for all three graphs? Look like it's in the same spot, doesn't it? Hold that thought. Now, I want to, let's see what changing a does, this number in front. I'm going to take this graph here, and I'm going to play around with a and see what happens. So f of x is a greater than or equal to 1. Let's let a be 2, and b is 2 times 2x. Get rid of that. Get rid of that. Get rid of that. So 2 times 2 to the power of x. See what the y-intercept is? Okay, but same shape, isn't it? Let's try a is 4. I'll just change this one. See what the y-intercept is? 1, 2, 3, 4. Any predictions what a might do? Yeah. Here, what was a? All of these were 1. But in every case where b was greater than 1, here it was 2 in both cases, how did the shape of this thing change? It didn't. It's exactly the same shape. Okay? But what happens now if b is not a nice number? What happens if b is between 0 and 1. In other words, what does that say to you? What's something that's between 0 and 1? A fraction? A proper fraction? Because not an improper fraction, because that would be greater than 1, right? Yeah. Let's just look at a couple of these. Okay, I'm going to let a be 1 again. So I got 1 times b to the x, but b is going to be between 0 and 1. So let's let b be 1/4. So f of x is a's 1. I'm not going to put it. B's 1/4 to the power of x. Clear. So in other words, 1/4, you got to put it in with brackets. Otherwise it won't graph what you want. You can use a decimal, 0.25. That'll also work. And is that going to make the same shape as all those other guys? A little different. Okay? See what the y-intercept is? All right. What if b is a bit bigger? If b is 1/2, a is still 1, but now I want to do 1/2 or 0.5. I'll put it on the same graph so I can compare. Let's do 0.5. 0.5, same as 1/2. Not quite as steep, right? So to exaggerate it, again, I want to emphasize it doesn't just end where it looks like the line is, because could I put in 10,012 for x in this graph and plot it? Yes, I could. All right? It would be a really, really, really small number, like 1/2 to the power of 1,000. Puny number, 1/2 times 1/2, 1/4, times 1/2, 1/8, times 1/2, 1/16, so on and so on. Okay? But it never, ever, ever gets and touches bound to 0 there. All right? There's a pattern here. The bigger the fraction, the closer to 1 it is, the flatter this graph is going to be. Okay? Last thing. I've talked a lot more than I usually do, right? I'm going to vary a, and b, I'm just going to keep as 1/2. Okay? I'm going to use this graph and play around with it. So let's let a be 2, and I'm going to graph here. F of x is 2, 1/2 to the power of x, and see what happens. 2 times 1/2 power x. Looks similar to this, but what do you notice? You see that y-intercept? What do you think a does in this thing? Not amplitude. I know I just went over sinusoidal stuff, okay? See what a does? If I put in this, any predictions on what the y-intercept's going to be? You betcha. I'm not even going to plot it. 1, 2, 3, 4. Same shape because b is a proper fraction. That is between 0 and 1. Now the y-intercept is 4. Okay. So there's some graphs to compare. Again, it's a lot like polynomials. It's not something you've seen before, but you can stick that in your noodle and memorize it like biology. But in general, for any exponential function, let's write down a couple of things. Characteristics. What are the x-intercepts of any one of these graphs? What do you see? How many times did these cross the x-axis? They didn't. And they ain't never gonna in proper English. Y-intercepts? I was trying to lead you into that, but let's write it down. A is the y-intercept. Okay? For all of them. So not much differences as far as like last chapter. Quadratics versus cubics, okay? Different things are going on. These are all the same as far as that goes. How about end behavior? What quadrants do these things go in? Do they all? Well, that's easy. Quadrants 1 and 2. Domain and range? You know, I do know some math teachers that would do this every day. Talk from bell to bell. Did you guys get any of them? X is all real for all of them. And y is greater than or equal to, nope, it's not equal to 0, is it? Never touches 0. Okay, where y is all real, but again, that's not as important as the y greater than 0 part. Okay, but to be proper, we have to put it. Okay, that's about it. So there's only 3 questions there. I said all.